Hello again, this is Susan Potts. I'm continuing on with using the quadratic formula to solve quadratic equations, that is second degree equations. And we just completed in the previous video 3 examples. In one of the examples we got 2 distinct solutions. In another example we got 1 repeated solution, and in the last example we got 2 complex values. Those had the letter I in them, had imaginary components. So this last little bit here that I wanted to discuss with you is something called the discriminant, and you can see here on screen that the discriminant is what sits under the radical in the quadratic formula. It's the b squared minus 4ac. Depending on the value of that discriminant, whether it's positive, 0, or negative, you can identify how many solutions you should expect from the second degree equation. So I've listed down here, let me scroll down and let you look at this chart. Again, the discriminant is this b squared minus 4ac. So if that discriminant turns out to be positive, that is greater than 0, we are going to expect 2 real solutions. And I went a little bit further because those of you who will go on and do graphing with this, when you're looking at a second degree equation, you're going to get some sort of curve, and some of them look like this parabola that you see out here to the right. When you get 2 distinct solutions, 2 real solutions, you get 2 x-intercepts when you graph, and you can see here I've pointed out each of these x-intercepts, the point where the graph crosses the x-axis. All right, the second case that we have is when that discriminant, that is the part that sits under the radical, is actually equal to 0, and you saw that in the previous video. We get 1 solution, and I went a step further again. If you graph that, you're going to see a parabola that touches the x-axis only once. It can be situated in different locations, can be turned upside down, it can be wide, flattened out, could be tall and narrow, but it's only going to cross the x-axis once. And the third solution, the third case here is if the discriminant, the part that sits under the radical, is a negative number, that is less than 0, that's when we got the 2 complex solutions, the solutions that contain the letter I. And if I take that a step further, when you look at the graph, you get a graph that doesn't cross the x-axis at all. So those are some things you're going to want to start to put together. So let's just do a couple of quick exercises using the discriminant to determine the number and the type of solutions. So all I'm going to do here, I'm not going to solve the whole thing. I'm just going to look at A, which in this first case is 1, B is 4, C is 4. All right, so I've just plugged in the numbers for A, B, and C. And now I'm going to do the arithmetic. So this is 16 minus 16, which gives me 0. All right, so let me scroll back here. I try not to make you seasick. When the discriminant turns out to be exactly 0, that means we have out here, that's what I wanted, 1 real solution. And again, if we were graphing something like this, I'll flip this one the other direction since I had the other one turned the other way. You would expect a parabola that only touches the x-axis once. All right, so again, let's identify A, B, and C here. We have it in standard form. That's the way we want it. A is 5, B is missing, and C is 7. So you plug in a 0 for B. All right, so b minus 4ac, 0 minus, I think that's 140. Of course, that's a negative result. So I quickly scroll back up here and look. When it comes out to be a negative result, I'm expecting two complex solutions. And again, just to take it one step further, if we looked at the graph of something like this, I don't know exactly how this one would look, but I know somehow that parabola would be situated so that it does not cross the x-axis. All right, and then the last one that I wanted to work for you here in terms of the discriminant, identifying A, B, and C. Make sure it's in the proper arrangement, and it is. A is 3, B is negative 2, C is also negative 2. B is negative 2, A is 3, C is negative 2, this is positive 4, and this is positive 24. Which is positive 28. So I'm getting a positive result, and that's the one where I get two real solutions. I don't have to go outside the set of real numbers into the set of complex numbers. So again, I don't know how it would look, but it would be some sort of a parabola turned some kind of direction so that it would cross the x-axis twice, accounting for those two real solutions. All right, so the last one I want to work, because this puts it all together here, is use the discriminant to determine how many and what type of solutions the following quadratic equation has, then use the quadratic formula to solve. So we have two steps here. We're going to first take a look at the discriminant. (36) minus 24 is positive 12, and since that came out to be a positive number, I'm expecting two real solutions. So let's go over here and work it. So now I'm just doing the arithmetic. So 6 squared is 36. Negative 4 times positive 6 times positive 1 is negative 12. I'm sorry, my brain is ahead of myself. Negative 24. And 36 minus 12, 24 is 12. That's the 12 my mind keeps trying to talk about. And I hope you remember how we simplify the square root of 12. We think of it as 4 times 3. And this square root of 4 right here, we're going to pull out from under the radical. So I've got two real solutions here. I think I'm going to go ahead and do a little more work on this. I hope you noticed that these this negative 6 over 12 and this 2 over 12 can be reduced down. My brain is ahead of my pen. And I wanted to say right here that 2 over 12 is actually reducing down to 1 over 6. Notice I don't go under the radical and try to do anything up underneath there. I'm going to keep that the square root of 3. So that's one solution, and because I'm running out of space here, the other solution is going to work out similarly, except this is going to have a minus in here. So these are my two real solutions that I was expecting. So I hope that helps you know how to use the discriminant to determine how many solutions to expect from the quadratic equation.